Welcome back. This is Mr. Marshall for Truganina College, Year 9 Maths. We're continuing on algebraic expressions and looking at factorising algebraic expressions. Today's learning intention, I am learning to factorise algebraic expressions by identifying the highest common factor, or HCF. Our success criteria is I will be successful when I am able to identify the HCF of multiple terms and able to factorise the expression using the HCF, the highest common factor. So the highest common factor, when we're factorising a number or an expression by writing out its product. So what we can do is look at the number 35 and we can factorise it by having it as 7 times 5 because they're the two prime factors for 35. So the factors of 35 are 7 and 5, and we can prove it by just dividing through and seeing that they form whole numbers. Now 5 outside of x plus 2 is also a factorised expression because this is really 5 times x plus 2. So the factors here are 5 and x plus 2, and we can show using our division that we learned earlier in the week that this is true. Okay, so let's have a look at a couple of basic factorizations. So we look at 15x. We've already got one factor here, we've got the 5x, we just need to work out the other number. Now if we do our division, 15x divided by 5x equals 3, so the other number has to be 3. Likewise, 15x squared divided by 3x, again we do our division, 15 divided by 3 is 5, x squared divided by x is just x, so the factor that's left is 5x. And this last one, negative 18ab squared equals 6a times something. So we divide by the 6a and we get negative 3b squared. The a's cancel out. 18 divided by 6 is 3. Negative divided by positive is negative. Okay, now let's have a look at some pairs of terms. So our highest common factor for each of the following pairs of terms. So we have 25a squared b and we have 10ab. So the way that we do this, it's a 3-step process. Step 1, let's write down 25a squared b in expanded form. So 25 becomes 5 times 5, a squared is a times a, and b is just a b at the end. Let's write this down as expanded form. 10 is 2 times 5, a is just a, and b is just b. Now let's look at what's common in both of these. We have a 5, and we have an a, and we have a b. So our highest common factor is 5ab. Let's look at this second one. We can go through the same process. We write 3xy as expanded, so that's 3 times x times y. We write negative 3xz as expanded. Now, negative 3 is actually negative 1 times 3 times x times z. Again, let's look at what's common. We both have 3's, we both have x's, so our highest common factor is 3x. So, let's practice by factorising some of these. We have these pairs. So first off, I'm going to work out the highest common factor for our 5x and our 15 using what I knew before, that is 5. So highest common factor is 5, so I write the 5 outside the brackets, and then I work out what's left by just dividing that 5 through. So 5x divided by 5 is just x, so that goes there. 15y divided by 5 is 3y, that goes there, and because there's a plus there, there's a plus there. And we can check this by expanding it back out. So we can go 5 times x is 5x, 5 times 3y is 15y. That's the same as our original question, so we know we're correct. Okay, we can do the same for the next one. So all 3 steps, highest common factor. Now we could do 7y or negative 7y, but negative 7y actually works a little bit better because it gets rid of that negative from inside as well. So if we bring the negative 7y out the front, so negative 7y divided by, or negative 14xy divided by negative 7y is 2x. And negative 7y divided by negative 7 is 1. So we just write plus 1 because the negative and the negative makes a positive there. And then again, we can check by multiplying this negative 7y into the equation to give us the original expression. And we check, and that's the same as our expression up there. Now this last one, let's go through it again. So we have our highest common factor is 3xy. 3 goes into both 6 and 9. There's an x for both of these, and there's a y for both of these. So we put that out the front of the brackets, and then we divide each by 3xy. So 6x squared y becomes just 2x, and 9xy squared divided by 3xy becomes 3y, and then we put them into the equation. We double check it again by expanding it out, and our expression is the same as what we started with. For today, you need to be practicing your exercises from pages 76 and 77 from your Jack Plus books, both online or on the text. And as reflection, I want you in 20 words to write what you learnt today, not what you did. So what similarities and differences of expanding expressions and factorizing expressions? So what are the similarities and differences between expanding expressions and factorizing them?